For the last review video that I'm putting together tonight, I want to show you how to predict the products of a chemical reaction. So in these cases, we've already been told what kind of reaction it's going to be, but I want to explain why we know that that's going to happen. So in the first one we have here is SiI4 reacting with Mg. I know that Mg is a metal. It usually makes positive ions, so it's probably going to switch into the first part here. And I know that iodine typically has a -1 charge. Mg is a group 2 metal, usually a +2 charge. So I'm thinking if this is a +2 and that's a -1, we're going to need 2 I's for every Mg. That'll make MgI2. And then silicon will get replaced and be by itself. So I see a single element coming in and reacting with a compound. The single element's going to replace whichever part it's more similar to. If it's a metal, it'll replace the first part. If it's a non-metal, it usually will replace the second part. So let's look at the second one here. We have Sb, which is antimony. That is reacting with I2. So we have 2 elements just kind of coming together. That to me looks like it's going to be synthesis. If I look up Sb in the periodic table, it is 3 groups away from being a noble gas. So in other words, it's below nitrogen and phosphorus. In that case, it usually likes to make 3 bonds because it has 5 valence electrons. It wants to make 3 more. So I would expect it to make 3 bonds with 3 iodides. And that would give me the formula SbI3. When I look at the third example, I have an ionic compound, CuCl2, that's got metal and nonmetal. That is reacting with another ionic compound, KOH. And OH, hopefully I recognize as the polyatomic ion hydroxide. So what's likely to happen is the Cu and the K will switch places. We'll get something like KCl, which has positive and negative parts to it, and we'll get something like CuOH2. I know that hydroxide tends to make -1 ions. Potassium is group 1, so it usually makes a +1 ion. Chlorine, usually -1. And since there's 2 chlorines here, the copper must have been a +2. So when I go to write the new formulas, the +1 K and the -1 Cl just make KCl. The +2 copper and the -1 hydroxide, I need 2 hydroxides for every 1 copper. Fourth example we have was ammonia, NH3, and that is just by itself before the arrow. So typically when you see something by itself before the arrow, the only thing it can really do is break apart. And when you have a relatively small thing to begin with, the only kind of decomposition it can go through is just to break down into its elements. So it'll break down into some combination of nitrogen and hydrogen. If you watch my last video, we mentioned Brinkelhoff elements. Those are the certain elements that like to be diatomic, where they pair up with themselves. So nitrogen doesn't like to be by itself. It'll make N2 molecules. Hydrogen will make H2 molecules, and then the way that this is written, it's not balanced. We need to balance it, and the final result you get is there on the next slide in the notes. Skipping ahead, if you go down to the second to last one, KClO3, it's by itself before the arrow. Typically, again, when we see something by itself before the arrow, that's going to go through a decomposition reaction. And this is potassium chlorate. ClO3 is chlorate. And we talked about chlorate. That's one of our 3 kinds of decomposition. What will happen is that this will give you KCl and O2. The metal stays with the chlorine, and then oxygen will make oxygen gas in the form O2. Again, not balanced, but we could take care of that and check our answer with what's on the next